Okay, we're going to get this done if it kills me. This is part 5, but we'll make this happen. So let's get back to this uh, situation here. We're going to go back to balancing these equations. So let's go down to this combustion equation, this combustion reaction. There's two other types of reactions that you don't see in this set of reactions here, because a couple of these, they don't quite fall into any of those the basic categories. It's kind of a combination of the two, but of a couple of different types. But I'll go review synthesis and decomposition reactions. So this next one here, this combustion reaction that we're going to look at, we've got this methane, CH4O2, becomes CO2 and H2O. But again, we want to make sure this is balanced. So this one here, now there's nothing that kind of stays together. Everything gets sort of mixed up. So I've got carbon, I've got hydrogen, and I've got oxygen. So I'm going to go to this other thing. We're going to set up our table here. So we've got our reactants and we've got our products, and on either side I've got the element name or like the symbol. So I've got carbon, hydrogen, and oxygen, carbon, hydrogen, and oxygen. So let's go back and do our count. So I've got 1, 4, and 2, and 1, 2, and 3. So 1, 4, and 2, 1, 2, and 3. So I've got 1, 4, and 2, 1, 2, and 3. And so obviously this is not balanced. Carbons look okay, hydrogens are a little bit off, and oxygen's off. Another thing that I'm gonna do, we didn't have to do it with the last one, but this one here, if you notice, this is a little sort of, not a trick, but you need to kind of recognize these things. The only way that I can balance these things is by finding a number, multiplying it by the number that I have, because those coefficients only multiply things. Those numbers that we put in front, they only multiply things on one side to try and balance it with the other. Well, an interesting thing happens if I have, so here I've got 1 and 1, they're already balanced. I've got 2 and 4. We can think of a number that we can multiply to make that make 2 4. I can multiply the 2 by 2 to make it 4. But but the thing is, when I've got this odd number here and an even number here, we can do a couple things. We can say, is there a common number that we can, or sorry, is there a common product that 2 and 3 would go into? For instance, like 2 will go into 6 and 3 will go into 6, so we call that the lowest common product. And this is one of the things that we're going to look at. But one thing that I usually look at is if I multiply numbers, I can take an even number, and no matter what I multiply it by, it will always be an even number. So I can never make an even number odd. So 2 can never become odd, but the 3, the odd number, can be even just by multiplying it by an even number like 2. So what if I take this and multiply it by 2, and this comes to the it'll end up coming to the lowest common product. But what if I take this 3 and multiply it by 2 to make it 6? Then it'll be even, and then I can make this 2 6 by multiplying it by 3. But let's go back and see if we can do that. So the oxygen, because there's 3 on the other side. Whoops, sorry, I got to be careful where I jump between these, because I'll lose them if I don't. But if I look at this, I've got this these odd number of oxygens over here, and I've got an even number here. So one way I can do that, I sort of said I was going to multiply that whole thing by 2, but I don't necessarily have to do that. What if I did this? What if I multiplied this? So I'm going to put my coefficients again are going to go in front of these. If I multiplied this by 2, if this number here is even, then I'll have an even number of oxygens, and no matter what number I put in front of CO2, I'm going to have an even number of oxygens. So let's do this. Let's just make them even on both sides first, and then see where that gets us. So I've got H2O. If I've got 2 water molecules, that means I've got 2 times the 2 hydrogen atoms. So I've got 4 hydrogen atoms here, and I've got 2 oxygen atoms. But I've got the, sorry, let me go back to that. I do have 2 over here, but I also have the 2 over there. So now that 3 becomes 4. Okay, so let me do this in red. So this 3 became 4. This, sorry, how did I do that? The 3 became 4. This hydrogen, the 2, also became 4. So now, the good thing is carbon looks to be balanced, hydrogen looks to be balanced. The only thing that's not balanced is the oxygen. Can I go back and if I multiply this by 2, that'll be 4 and it will be balanced. So let's go see if that makes sense over here. Well, look, I do have O2. If I multiply this by 2, maybe I should do this one too. No, I can't do that. I'll just override it. 2. So we multiply that by 2. So now I've got 4 oxygens. And sure enough, so I have it, it's balanced. I've got 1 and 1, 4 and 4, and 4 and 4. Let's go back to make sure that we've done it right here. So I look at this, I've got 1 carbon, 1 carbon. I've got 4, why does that number keep disappearing on me? I've got 4 hydrogens. Oh, I know, because I've got those white marks underneath, and I switch back and forth. So I've got 4 hydrogens. I've got 2 times 2 is 4. I've got 2 times 2 oxygens is 4. And I've got 2 oxygens plus another 2 oxygens is 4. So that's balanced. And this is a balanced combustion reaction. This next one here, again, I guess this could be, it's kind of like a single displacement in that the oxygen sort of bumps out the sulfur, but then some of the sulfur recombines with the oxygen. So it's kind of like a single displacement and a synthesis reaction. So it's a combination of the two. But let's get to business here. We want to see what we can do to balance this equation. Let's see if we can do this without going over to the table. Oh, no, let's use the table. So I've got zinc, sulfur, and oxygen. I've got 1, 1, and 2, 1, 1, and 3. Okay, so 1, 1, and 2, 1, 1, and 3. So let's go to our table. Let's scroll down a little bit. So again, our reactants. We've got reactants. We've got products. We've got zinc, sulfur, and oxygen. What did I say? 1, 1, and 2. And we've got zinc, sulfur, and oxygen in 1, 1, and 3. So it looks like the oxygen is what needs to be balanced at this point. Okay, so, but, let's go back to that sort of rule. Remember, I can't make an odd number or an even number odd, but I can make an odd number even. Let's go see how we can take care of that on this one here. So we have an even number of oxygens always in the sulfate, sulfur dioxide. We always have 2 oxygens here, but this one here I can have 1, 2, 3, whatever I multiply this. If this is not an even number, then this becomes this has to be an even number to make this even. So how about let's try that. Let's make this 2 and see where this gets us. So I've got yes, I've got 2 zinc, like 2 zinc oxides. So let's go back to the note over here. So I've got, sorry, do this in red. I end up with 2 over here. But now the oxygen, I've got 2 plus 2 is 4. But I've sort of messed things up a little bit. So, but with any luck, we'll be able to make a few more changes, and we'll be able to get back there. So let's go to the equation. Okay, so we've done that. Now let's go back to that note. So I've unbalanced the zincs. So let's see if we can balance those zincs again. What if I put a 2 in front of here? So sometimes it'll go back and forth. You may have to do it in a couple of steps. So we've got 2 zinc sulfides. So I'm going to increase the zincs. I'm going to multiply that by 2. And then this becomes 2. But now I've unbalanced the sulfurs. Let's, so the sulfurs need to be balanced. So this gets more interesting. So I've got 2 of these. How about I put 2 of these? And so now I will have 2 sulfurs, but I'll have 2 times 2, 4 oxygens plus another 2. So I'm going to end up with 6 oxygens now because of this change to balance the sulfurs. The sulfurs will be balanced, but the oxygens will be knocked out again. So the sulfur becomes 2. This becomes 6. So the only thing that's unbalanced now is the oxygen. Let's see if we can't fix that. Well, if I have 6 oxygens on this side, I've got 2 over here. What if I multiply this by 3? Then I go back here and I multiply that by 3. That becomes 6, and I've got it balanced: 2, 2, and 6. And this is our balanced equation, our balanced sort of combination, single displacement synthesis. A weird combination. Anyways,